through the Section 6 mixed practice problems and show you the solutions here. Number 1, a family has 6 children. What's the probability that they have at least one girl? Notice at least, and so we're going to think back to our approach. The probability of at least one girl would be equal to 1 minus the opposite of that, which would be the probability of having no girls out of 6 children. So that's going to be the easier route. So 1 minus, well, if I have no girls, that means I have all boys. And so there's a 1 out of 2 chance that the first one's a boy and the second one's a boy, third, fourth, fifth, and sixth. Keep working through this. We get 1 minus 1 out of 64, which is 64 over 64. That's your 1 minus 1 out of 64. And that comes out to be 63 out of 64. Number 2, a gum manufacturer randomly puts one coupon in one of every 4 packages. What is the probability of getting at least one coupon if 4 packages are purchased? Okay, so again, the probability of at least 1 is 1 minus the opposite of that, 1 minus the probability of no coupons, or 1 minus, well, if so what's the probability the first one doesn't have a coupon? Well, 3 out of 4, because 1 out of every 4 has one. So 3 out of 4 does not. And the probability the next one doesn't have it would be 3 out of 4. We're picking 4 packages, third one and the fourth one. So 3 out of 4 times 3 out of 4 times 3 out of 4 times 3 out of 4. That together is the probability that all 4 of the packages will not have a coupon. And continue to work through this. We end up with 1 minus 81 out of 256. 1 is 256 out of 256. Minus 81 out of 256. That comes out to be 175 out of 256. Number 3, I flip a fair coin 3 times. What's the probability of getting at least, notice the at least, one head. So that would be the probability of at least 1 is going to be 1 minus the probability of having none. So 1 minus, so we're going to flip the coin 3 times. So 1/2 times 1/2 times 1/2, or 1 minus 1/8. So we get 7/8 as an answer. 4, 2 standard dice are rolled. What's the probability at least one of them is not odd? Instead of not odd, we could just think of that as even, right? And at least, again, let's think of the opposite of that. So the probability that at least 1 would be 1 minus the probability that none of them are even. So it'd be 1 minus the probability that they're both odd. Okay. So 1 minus, well, there are 3 odd numbers out of the 6, and another 3 out of the 6. You can reduce those to 1/2 and 1/2. So we end up with 1 minus 1/4, which is going to be 3/4. Number 5. Alex wore blindfold and shot an arrow at a target shown. Judging by the noise made on the impact, you can tell that he hit the target. What's the probability that he hit the shaded region? Okay. Well, it's the whole circle together, the complete area, is going to be 64 pi. Remember, the area of a circle is pi r squared, so that's the complete area. And then the area of the small circle would be 4 pi, again, pi r squared. And so the answer is going to be the small area over the large area, reduced. You divide by pi, and divide top and bottom by 4, and we get 1/16. Number 6, suppose that a dart is as likely to hit a round dartboard at any point as any other point. What is the probability of hitting the shaded region? And notice the shaded region makes up half the dartboard, and so the probability would be 1 out of 2, which is 50%. Number 7, you own 17 pairs of socks, all different, and all the socks are individually jumbled in a drawer. One morning you rummage through the drawer and continue to pull out socks until you have a matching pair. How many socks must you pull out to guarantee you have a matching pair? Well, there is a possibility of pulling 17 out of that drawer, and all 17 of those socks are different because there's 17 different pairs of socks in there, right? But once you grab that 18th one, that one has to match one of the 17, and so 18 would be the minimum number of socks that you'd have to draw to guarantee that you will always have a matching pair. 8, a sock drawer has hundreds, each of red socks, green socks, and blue socks. Hundreds. One day, Anne pulls out 40 socks randomly and gets the maximum number of pairs of matching socks. Okay, so for Anne, if she pulls out 40 socks, the maximum number would be 20 pairs. As many pairs as she can get. For Bob pulls out 40 socks and gets the minimum possible number of matching socks. How much is the difference between their numbers of matching pairs? And this one's maybe a little harder to get your head around. And so what I'm going to do here is I'm going to create a little table, and we're going to look at a chart here. So we got Anne, we got Bob, we got the difference, and let's go number of socks. And how many? We got red, green, and blue. Those are our colors. So let's say we pick 3 socks. Well, let's go 4 socks. Start with 4. So Anne can, the maximum, Anne's gonna get the max. Bob's gonna get the min, okay? Number of pairs. So Anne, 2 pairs would be the best you can do. Bob, if he's got 4 socks, the worst he can do is, the first 3 he picks is red, green, blue. but that fourth one's going to match one of them. So he's going to have one pair that's going to work, and so the difference between that is 1. 2 minus 1 is 1. Let's go with 5 socks. Best Ann can do with 5 socks is 2 pair. The minimum that Bob can do here with 5, let's see, if he gets red, green, blue, so you get another red, and then get another red. So we still, the minimum, we have 1 pair only. So the difference is still 1. Let's go with 6. And best she can do is 3. For Bob, if he went red, green, blue, red, red, that's the worst you can do. And if you add one more, no matter what, it's either going to be green, blue, or red, and you're going to have a matching pair. So let's say it's green. So that should be a G. So now it's got two pairs. So the difference is 1. 7 socks. Best Ann can do is 3. Bob, well, say he picks another green, so still needs something else to match, so he's still got 2. Difference is 1. So notice the pattern here. The difference is always 1. And you can do this as much as you want, but you'll see that the difference will always stay 1. So 8, you get 4 here. No matter what, you're going to increase this. You get another pair here. You get 3 for the minimum. You get 1, and so on. So once you see that pattern, you're going to find out, okay, Bob's going to have 19 pairs of socks. The difference is going to be 1. 1's the answer to 8. Number 9. What is the probability I draw 2 socks of the same color if I draw randomly from a drawer with 4 gray socks and 3 black socks? So we got same color, so it's either going to be gray, gray, or it's the probability of gray, gray, plus the probability of black, black. All right, so first one, gray, gray, so you get 4 out of 7, and then 3 out of 6. Black, black is going to be 3 out of 7, and 2 out of 6. And then you just work through this. Let's see here, we end up with, I'm going to reduce a little bit, so 3 out of 6 is 1 out of 2, 3 out of 6 again, and then we can get rid of the divide by 2. So we end up with 2 over 7 plus 1 over 7, which is 3 out of 7 as an answer for 9. A person at random from a certain group of college freshmen, the probability of the individual woman is 0.55. Individual man is married is 0.1, and the probability of the individual is a married woman is 0.5. What's the probability the individual is married or a woman? So the probability of married or a woman is going to be the probability of being married plus the probability of being a woman minus the probability of being married and a woman. So married is 0.1, woman is 0.55, married woman is 0.05, and you end up with 0.6, which is 3/5. Probability of A is 0.3, so on to number 11. Probability of A is 0.3, probability of B given A is 0.6. Find the probability of A and B. So the probability of B given A is equal to the probability of A and B over the probability of A. That's the formula. And so plugging stuff into that formula, we get 0.6 is equal to x over 0.3. So x is going to be 0.6 times 0.3, which is 0.18. And if you change that to a fraction, you'll get 9 out of 50. A and B are two independent events. Probability that A occurs is 2/5. Probability that B does not occur is 5/6. So that means the probability of B would be 1 out of 6. What's the probability that both A and B occur? So they're independent. So the probability of A and B is the probability of A times the probability of B, which is 2/5 times 1 out of 6, which is 2 out of 30 or 1 out of 15. 13, what's the probability that the sum of two different single-digit prime numbers will be prime? All right, so what are our single-digit prime numbers? We got 2, 3, 5, 7, that's it. There's only 4 single-digit prime numbers. So what's the probability that the sum of two different single prime numbers will be prime? So I'm going to create an addition table with these to look at the sums. And now I'm going to circle the prime numbers. So we got 5, 7 for sums. Looks like there's only 4 of the sums of the 16 are prime, which is 1/4. We reduce that. But I did overlook something. Two different single-digit prime numbers. So I have to scratch out the ones. So 4 came from the same, 6 came from 3 plus 3, 10 came from 5 plus 5, and 14 came from 7 plus 7. So we need to ignore those. So it's not 4 out of 16. It's going to be 4 out of, how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4 out of 12. And that comes out to be 1 out of 3. All right, 14. Pedro has exactly 4 blue pens, 8 black pens, 3 red pens in his backpack. If he pulls out one pen, then keeping that one out for himself, pulls the second one out, both without looking, what's the probability that both pens are black? So first one, we got 8 black pens out of 15 total, and then 7 black pens out of 14 total. And then you just multiply and reduce. And when you work through that, well, let's see here. 7 out of 14 is 1/2. And then the 8 and 2 can reduce. So you end up with 4 out of 15 for an answer. 15, an integer x where x is between 10 and 99 is to be chosen. So how many numbers are there? And you're going to get 90 different numbers there. Because you're including 10, you're also including 99. If all the choices are equally likely, what is the probability that at least one digit of x is a 7? Okay, so you have 17, 27, 37, 47, 57, 67, 77, 87, 97. Those each include sevens. But then you also have 70, 71, 72, 73, 74, 75, 76. We got 77, 78, 79. So we have 10 here. 11, 12, 13, 14, 15, 16, 17, 18 out of the 90 numbers. Divide by 9, you get 2 out of 10, which is 1 out of 5. Number 16. A number n is chosen randomly among the first 60 positive integers. What is the probability that n is a prime and that n is a multiple of 13? Well, 13 is prime, but any multiple of 13 beyond that is not prime. 13 times 2, 13 times 3, 13 times 4, those are not prime. So there's only one prime number that is a multiple of 13 out of 60. So 1 out of 60 is our answer. 17. In a regular heptagon, heptagon has 7 sides. Each vertex is joined in turn with the vertex that is 2 away going clockwise. What percentage of all the possible diagonals are now drawn in? So a heptagon has 7, 1, 2, 3, 4, 5, 6, 7 vertices, right? And each vertex has 6 different ways it can connect, right? So this, like if I'm looking at this one right here, okay? It has 6 different points it can connect to. 1, 2, 3, 4, 5, 6 different options. So again, there's 7 vertices. Each of those 7 vertices have 6 different connecting points. But if you look at one of the connecting points, each connecting or each segment uses two vertices. And so which one did it start with? Well, if I do 7 times 6, one of them started with 1, and one started with the other. So we have to we have double of what we want. We have to divide by 2. And so we end up with 21 different possibilities for all diagonals. Okay. Now in our case here, we start with our 7. 1, 2, 3, 4, 5, 6, 7. And let's say I focus on this vertex here. It connects to 2 away going clockwise. So that can only connect to this one. So that's 1. This one connects to this one 2. And go here. 3. Here. 4. Here goes to 5. Here goes to 6. Here goes to 7. All right, so we have 7 out of 21, which is 1 out of 3. And I think I don't think the answer chart has that. And so this right here is going to be 1 out of 3. Okay, 18. 7 vampires and 8 werewolves met in the forest. During the meeting, a grizzly bear jumped out and randomly mauled 3 of them. What's the probability that all 3 were vampires? All right. So we got 7 out of 15, and then 6 out of 14, and then 5 out of 13. And we can reduce that. And we end up with 1 out of 13. All right. Next page. Number 19. 2 numbers are chosen randomly from the set 1 to 20. What's the probability that the 2 numbers are consecutive? Consecutive means next to each other, like 2 and 3, or 5 and 6, and so on. Well, we need to think of this in 2 ways. Let's think about our first pick. Okay. So our first pick can be one of the ends, like a 1 or a 20, or it can be something in the middle, 2 to 19. And it's important to distinguish those because the 2 to 19, like if my first pick's 2, then I have 2 options for my next one. Like I could pick a 1 or a 3. But if my first pick was a 20, then I only have 1 option. I can't pick 21 because that's not in there. I can only pick 19. So for your first pick, it's going to matter if you pick a 1 or 20 versus having your first pick be 19. So I'm separating those 2 cases. Case 1 and case 2 for your first pick. So let's say my first pick was a 1 or 20. So I pick 1, so there's 2 of those out of 20 possibilities. I pick a 1 or a 20. Then if I pick a 1 or if I pick a 20, how many options do I have for that consecutive one? So if I pick a 1, then I have to pick a 2. There's only 1 option. If I pick the 20, then I have to pick the 19. Only 1 option. So there's only 1 option out of 19. Now case 2, let's say I pick a 2 through 19. Well, there's 18 of those numbers out of the 20. And if I pick any of those, then if I want to pick something consecutive to it, like say I pick the 2, I have 2 options. I can either pick the 1 or the 3. Or if I pick a 7 first, then I can pick the one below it or the one after it. So no matter what I picked here, I can pick below or after. So there's 2 options out of the 19. So this together is going to give us what we're looking for. So we end up with 2 plus 36 over 20 times 19, or 38 out of 20 times 19. And let's work on reducing that. 19 divided by 19 divided by 2. So you get 1 out of 10. 1 out of 10 chance. All right, Joey typed 3 letters in 3 envelopes. But then Mary put them in the envelopes randomly. What's the probability that no letter is in the correct envelope? All right, let's say we have 3 letters, 1, 2, and 3. And the correct ordering would be A goes with 1, B goes with 2, the letter A, letter B, letter C should go with 3. So how many ways can we really mess this up where no letter is in its correct envelope. So I can't put A with 1, I can't put B with 2, and I can't put C with 3. Well, if A can't go with 1, then either B goes with 1 or C can go with 1. If B goes with 1 and B can't go with 2, then, sorry, if and B, well, B's not going to go with 2. A can go with, well, we can't have C here, so A would have to go with here, and C would have to go here. So there's only one way in which we can start with the B. We're going to find there's only one way you can start with the C, too. You have to put the B here and A here, I think. Let's check. Yeah, because you can't put B in the second spot. So there's two ways out of, well, how many different ways can we arrange things? Well, if I have 3 letters, I have 3 options for my first envelope, 2 options for my second, 1 for my third. So this would be 2 out of 6, which is 1 out of 3. Number 21, couples planning their wedding. They can select from 2 different chapels, 4 soloists, 3 organists, and 2 ministers. How many different wedding arrangements are possible? Let's multiply that together. You got your answer, 48. 22, Ravi has loaded 12 songs on his MP3 player, 4 rock, 4 soul, and 4 jazz. He sets his player to play each song once in a random order. What's the probability that the 4 rock songs will get played first? So there's 4 out of 12. And then there's 3 rock songs left out of 11, and 2 out of 10, and then 1 out of 9. And you work through this and simplify it down. Let's see here, divide by 4, divide by 3, divide by 2. We end up with 1 out of 495. 23, Carl's iPod playlist contains 20 songs, 3 of which are reggae. He randomly shuffles a song. What's the probability that 3 reggae songs will appear first? So we got 3 out of 20, 2 out of 19, 1 out of 18, and just continue to reduce and multiply it out. And we end up with 1 out of 1,140. 24, in the federal court of Eastern California, the jury pool is 10 million. Of this number, 4 million are OTW, and a randomly chosen jury, 12 people, we should expect how many OTW? Well, you got 4 million out of 10 million, or 2/5 of the people are OTW. So out of 12, we're going to find 2/5 of 12. So 2/5 times 12 is 24 out of 5, which is 4.8 roughly. So we round to about 5 people. 25, a survey of a group of 50 students showed that 14 were taking chemistry, 10 physics, and 3 were taking both. If a student is chosen at random from the group, what's the probability the student will be taking chemistry or physics? Okay, so the probability of chemistry or physics is the probability of chemistry plus the probability of physics minus the probability of both, one and the other, right? So survey of 50 students. So 14 out of 50. Physics, we got 10 out of 50 minus 3 are doing both out of 50. So that's going to be what, 20, 21 out of 50? And last one or last one for the page. At Pine Summer Camp, 60% of the children play soccer, 30% swim, 40% of the children who play soccer swim to the nearest whole percent. What percent of non-swimmers play soccer? All right. I'm going to make a little table here. We got soccer players, and we have those that don't, non-soccer players. Just need to organize this information a little bit. We have those that swim, and we have the non-swimmers, right? And it says that 60% play soccer. So I'm going to put 60% of the people here play soccer. That means that 40% don't play soccer, right? That makes 100% of the total here. 30% of the children swim. That means that 70% of the children do not swim. 40% of the children who play soccer. So 40% of the 60%. I need to multiply that. So 0.4 times 0.6 is going to give me 0.24. So I get 24% here. And now I could start to fill in the rest. So 24 plus 6 is 30, so that's 6% here. 6 plus what is 40, so that's 34% here. And 24 plus 36 goes here. And so now we want to know what percent of non-swimmers, okay, what percent of the 70% play soccer? So what is the 36% out of 70? And that comes to be about 51%. Okay, 27. The numbers 1 through 10 are put in a hat. If the numbers are taken out one at a time, what's the probability they come out in ascending order? Ascending means lowest to highest. So I pick the 1 first, so 1 out of 10, and then I pick the 2 first, 1 to 9, there's 1 here, and then I pick the 3, there's 1 3 out of the 8 remaining, and so on. And that's going to be 1 out of 3,628,800. 28. 3 X's and O's are arranged randomly in a line. What's the probability that we get this particular arrangement? So if we think about, well, how many different words are possible with 3 X's and 3 O's? Well, we know there's 6 factorial over, and I got 3 repeats for X's, 3 repeats for O's. I work through that. Reduce this, work. Let's see what we end up with. End up with 20 different ways to arrange the X's and O's, and this is one of the 20. So that is our answer, 1 out of 20. 29, a game involves correctly choosing the 5 randomly drawn numbers out of 1 through 18. What's the chance of winning? Well, let's see here. We're going to choose 5 numbers out of 18. So for the denominator, how many different ways can that happen? Well, 18 times 17 times 16 times 15 times 14, right? And we're going to pick the exact 5 that we want and that we need. And so there's one way to do that out of this. And so we get but actually there's only one way if the order didn't matter, and I did this as if order mattered, so I need to divide this by 5 factorial because we're treating it like order does not matter. So it's going to be, once I simplify all that denominator part, we're going to get 8,568. All right. Number 30, a class has 3 girls and 3 boys. These students line up at random, one after the other. What is the probability that no boy is right next to another boy and no girl is right next to another girl? So you have, well, you can start with a boy. So you have the probability of that happening, or you can start with a girl. Okay. So there's 3 boys out of 6, and then you have 3 girls out of 5, and then 2 boys out of 4, and then 2 girls out of 3, and then 1 boy out of 2, and then 1 girl out of 1. And then we can do something similar for the next part here. So pretty much copying down the same thing. And you simplify and add. And we're going to get 1 out of 20 plus 1 out of 20, which is 2 out of 20, and that reduces to 1 out of 10. So there's a 1 out of 10 chance. 31. We have a bookshelf that has 3 math books, 4 history books, 5 biology books. If 2 books are picked at random, what's the probability that they're both math books? All right. So we have 3 math books to pick for the first option out of 5, 6, 7, 8, 9, 10, 11, 12. And then we have 2 math books left out of the 11. And then you just walk through this, divide by 6, and we end up with 1 out of 22. Number 32. Of the 10 teachers who have volunteered for a school committee, 3 are men and 7 are women. If 3 of those people are chosen randomly, what's the probability that at least one of them will be male? All right, you got that at least one here. And so for 32, remember the probability of at least 1 is equal to 1 minus the probability that none are chosen. Right? So that's going to be 1 minus the probability that none are male or all are female. So there's 10 teachers, and 3 are men, 7 are women. So the first one's a woman, will be 7 out of 10, and then 6 out of 9, and then 5 out of 8. And then you just work through this problem here. If we reduce here, let's see, we have divide by 5. We could divide by 6. and we end up with 7 out of 24. 1 is 24 out of 24. And so we end up with 17 out of 24. Number 33, Joey and Josh and 3 other boys line up randomly. What's the probability that the other 3 boys will be between Joey and Josh? All right. Well, let's say we start with Joey and then end with Josh, and you got 3 in between. Oh, there's only one way to pick Joey, and there's only one way to pick Josh, and you got 3 options for the pick here and 2 options and 1 here, right? So we end up with 6 different ways to start with Joey and end with Josh. And there are also 6 ways to start with Josh and end with Joey. Same reasons. So there's 12 total ways out of, well, how many different ways can you arrange 5 people? 5 options for the first place, and then 4, and then 3, then 2, then 1. 4 times 3 is 12. And so this ends up being 1 out of 10. Number 34, a fair coin is tossed 4 times. The probability that the results alternate is 1 out of how many? Consider here, 1 when we start with heads, and 1 when we start with tails. So that's the probability of getting heads, tails in that sequence, or getting tails, heads in that sequence. So 1 half times 1 half times 1 half times 1 half for the probability of heads, tails, plus 1 half times 1 half times 1 half times 1 half for the probability of tails, heads. So it's 1 out of 16 plus 1 out of 16, which is 2 out of 16, or 1 out of 8. And it's saying 1 out of how many? Well, 1 out of 8. So 8 is our answer to number 34. 35, 5 coins are flipped onto the floor. 4 of them are randomly picked up and observed to be heads. What's the probability that all the coins are heads? Well, we already know the first 4 are heads. So it's really saying, hey, what's the probability that that last coin is heads? So there's a 1 out of 2 chance. 36, 2 national park quarters are each flipped twice. What's the probability that each park side comes up exactly once? All right. So these are quarters, and your quarters sides has heads and tails. There are different types of quarters. One has one national park, one has another national park, and on each side of the quarter, one side has a national park and the other side doesn't. National park. Let's say this is equivalent to saying, "Hey, I'm flipping one coin, and I can get. I'm going to flip it twice. So you have 4 flips here. Your first, second, third, and fourth. And the first 2 flips come from coin 1, and the next 2 flips come from coin 2. Okay. And what they want here is, if I get heads on the first flip, I need to get tails on the second. Or if I get tails on the first flip, I have to get heads on the second. Same with coin 2. So if I get heads here, I have to get tails here. Or if I get tails on the third, I have to get heads on the fourth. So another option would be heads, tails, heads, and tails, heads, heads, tails. And those are the only four things, four ways that we can do this. Out of, well, if it didn't matter, we got two possibilities for each, which gives us 16 ways. And so 4 out of 16, or 1/4, would be the answer to this. Number 37. If a pair of standard dice is rolled 3 times, what's the probability that the sum of 7 is not obtained on any of the rolls? Right, so you have a pair of standard dice rolled. Now, if we trail back, let's see, I think we have a sum table somewhere around here. I'm looking for it. Maybe I didn't make one. Thought I did. I guess not. So I'll make one right here. What I want you to see here is how many times 7 comes up out of the 36 options. And you see that it comes up 6 times. So the probability that you get a sum of 7 with 2 rolls is 1 out of 6, or 6 out of 36, right? We're going to use that here. So I'm going to do this 3 times. And I don't want a sum of 7. So probability of not getting a sum of 7 would be 5 out of 6. Because the probability of getting sum of 7 is 1 out of 6. The probability of not getting a sum of 7 is 5 out of 6 for the first roll. And I don't want it for the second roll either, or second trial, or for the third trial. And so we get 125 out of 216. All right, 38. An unfair coin is twice as likely to land heads as tails. If the coin is tossed twice, what's the probability that it will land tails both times? So it's twice as likely to land heads than tails. Okay. So when I flip a coin, this would represent twice as likely to represent heads than tails, right? So you have a 2/3 chance. The probability of heads is 2/3, where the probability of tails would be 1/3. Right? Heads is twice as likely as tails. And I want to land tails both times. So the probability of tails would be 1/3, and then probability of tails, the next one would be 1/3. So you get a 1 out of 9 chance. All right, 39. An urn contains 12 red and 16 blue marbles. 2 marbles are drawn in succession without replacing the first marble. What is the probability both are red? So you got 12 red out of 28 marbles times 11 red out of 27 marbles, and then just work on reducing this the best you can. Let's see, if I divide by 3 and divide by 4, and we end up with 11 out of 63, number 39. Number 40, An urn contains 4 blue balls, 5 red, 6 green. 2 balls are drawn in succession without replacing the first. What's the probability there is 1 red and 1 green? Okay. All right. The first one can be red, and the second one can be green. Or the first one can be green, and the second one can be red. So the first one's red. We have a chance of 5 out of 15. And then the second one being green would be 6 out of 14. And the first one being green would be 6 out of 15. Second one being red would be 5 out of 14. And just need to work through this, simplify it down, and see what we get. So 5 out of 15 is 1 out of 3. Divide by 6. So we end up with 1/7 plus 1/7, which is 2 out of 7. All right, number 41. 2 marbles are drawn from an urn, which contain 3 yellow, 3 red, 5 blue. What's the probability at least one of them is red? Okay, so we got that at least one. So probability of at least one is 1 minus the probability that none are red. Okay, so 1 minus, all right, so I don't want a red, so no red. So how many are not red? Well, that's 8. You got 3 yellow and 5 blue out of 12. And I want the next one not to be red either, so 7 out of 11. And then work towards reducing this. You could divide by 4. And I'm left with 2 out of 3. So I get 1 minus 14 out of 33. 1 is 33 out of 33. And 33 minus 14 is going to be 19 out of 33. All right, 42. An urn contains 6 red, 3 white, 2 green. 2 balls are selected together at random. What's the probability that the 2 are the same color? So we want the probability that we get 2 red, or probability that we get 2 white, or the probability that we get 2 green. All right, 2 red, well, that's 6 out of 11. And then 5 out of 10. Plus 2 white, we got 3 out of 11 times 2 out of 10. Plus, we want 2 green, so we got 2 out of 11 times 1 out of 10. So that's going to give us what? 6 times 5 is 30, 3 times 2 is 6, 2 times 1 is 2 out of 11 times 10. Just 38 out of 11 times 10. We can reduce this. 38 cut in half is 19 out of 11 times 5. So 19 out of 55 is what I get, which is C. 43. 5 songs that are played in random order. 2 of the songs are by the same group. what's the probability that these two songs are not played consecutively? All right, so we have 5 songs. Let's say song A, B, C, D, E. And 2 of the songs are by the same group. What's the probability that those 2 songs are not played consecutively? So let's say A and B are played by the same group. Okay. So those are the 2 that are from the same group. So we don't want to, if we play song A somewhere in this set, we don't want to play song B next. Or if we play song B first, we don't want to play song A next, right? So first of all, how many, say we didn't worry about anything, so the total number of possibilities, we got 5 options for the first song, and then 4, then 3, 2, and then 1. All right. And that comes out to be what? We got 20 times 6, so 120 ways. Now, in that, let's say we don't want A, B anywhere. And so what we're going to do, we're going to glue A and B together and think of this as 4 different song groups. We're gonna think of playing A first and playing B second as one. And so in this case, we are going to have 4 options, and then 3, and then 2, and then 1. And by doing this, we have, we multiply this together, we get 24 ways that A will be played right before B. What if we want to do this now? Let's glue these together, B, A, C, D, E. So again, we got 4 options. So again, we got another 24 ways, and in those 24 ways right here, we're going to assure that B was played right before A. So there's a total of 48 ways where those 2 songs will be played consecutively. So there's a 48 out of 120 chance that you will play them right next to each other, that you will play them consecutively. We don't want to play them consecutively. Let's reduce this a little bit. We got 24 out of 60, 12 out of 30, 6 out of 15, 2 out of 5. Okay. So what I want is the opposite of this, right? Because I found that there's a 2 out of 5 chance of playing the 2 songs right next to each other. So there's a 3 out of 5 chance of not playing them next to each other. I want the backdoor approach here. All right, number 44. You have a 3 by 3 by 3 cube painted on 3 mutually adjacent faces. Okay, so a cube has 6 sides, and you're going to paint only 3 of the faces. So paint this 3 faces that we see. Okay, so the top, and kind of the right side and the left side here. And each of these sides are broken up.
Alright, and each of these sides is cut up into 9 cubes. And all these cubes are, this big cube, 3 by 3 by 3, is split into 27, 1 by 1 by 1. And so some of those 1 by 1 by 1 cubes will have no faces painted at all, and others will have some of the faces painted. And we got to figure out what we're looking at and what we're working with. So how many of those cubes will have 3 faces painted? And if you think about it, you're only going to have one. And it's this top corner one. The one you got 3 faces here. The one, and that's the only cube that will have 3 faces painted. Then you have, and I'll change colors here. Like this cube here has 2 faces painted. That's one. Here's another one. You got one over here, 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 and here. You have 6 cubes that have 2 faces painted. And then you have some cubes that have only 1 face painted. One I'm putting blue dots on. So you got 4 here. You got 4 up here, 4 on this side, so we got 12 cubes that have exactly 1 face painted. And then the remaining have no faces painted. Well, how many? You have 27 cubes total, and we've accounted for what? 12, 18, 19. So we have 8 cubes remaining. Excuse me. Alright, so I'm going to randomly pick a cube. Now I may, if I pick the cube with 3 faces, the probability that I pick that one is 1 out of 27. And if I were to pick that cube, I also want the top face to be painted. And on that particular cube, 3 of the 6 faces are painted. Or what else could happen is I could pick one of the cubes that have 2 faces painted. Well, what's the probability of that happening? Well, there's 6 out of 27 cubes. And if I pick one of those, well, what's the probability that I roll a painted side? Well, there's 2 faces on each of those that are painted out of the 6. Or I can pick a cube that has only 1 face painted, and there's 12 out of 27 of those, and of each of those only 1 face is painted out of the 6. Or I may pick a cube that has no faces painted, and there's 8 out of 27 of those, and well, what's the probability that I roll a painted side? Well, none out of 6. So this piece right here is just 0. Alright, so we got 3 times 1 plus 6 times 2 plus 12 times 1 all over 27 times 6, which is 24, 25, 26, 27 over 27 times 6. Divide top and bottom by 27. You end up with 1 out of 6. There's a 1 out of 6 chance that this would happen. So B is the right answer. Alright, on to number 45. Almost there. 2 more problems. A cup holds 5 green pens, 6 red, 7 blue, and we grab 3 pens. What's the probability she gets 1 of each color? So that's probability of getting green, red, blue, or green, blue, red, or blue, green, red, or blue, red, green, or red, blue, green, or red, green, blue. So there are 6 different options here. And each of these options actually are going to end up being the same exact probability, and I'll show you that. So the probability of the first one, green, red, blue. So we got 5 out of what? 7 plus 5 plus 6 is we got 6 out of 17 now. And blue we have 7 out of 16. We'll do one more here just to show you it's the same. Green, we got 5 out of 18. Blue, we got 7 out of 17. And red, we have 6 out of 16. Now notice the probability for green, red, blue. If I were to multiply that together, I get the same thing as if I multiply the green, blue, red together, because the numerators will be the same. You got 5 times 7 times 6, or 5 times 6 times 7, same thing. And the denominator is the same, 18 times 17 times 16. So we end up with 6 of these. Okay, this one will be the same and same and same. So this is going to end up being, you got 6 times, I'll do 6 over 1, times one of these, so 5 over 18, 6 over 17, and 7 over 16. And then we just reduce this as much as we can. Divide by 6. Divide by 6 again. And that's about as good as we can get. So we have 35 in the numerator and 17 times 8 in the denominator, which is 136. And there we have it. Alright, last one. 6 Easter eggs are in a basket. 2 blue, 2 yellow, 2 red. If 3 eggs are selected randomly, what's the probability that one of each color is chosen? Okay, so we want the probability of blue, yellow, green, or again, there's 6 ways, and each one is equally likely. So it's going to be 6 times one of these probabilities. So let's see, blue, we got 2 blue out of 6. And then yellow, we got 2 yellow out of 5. And then green, we got 2 green out of 4. And now we reduce. Divide by 6, divide by 4, and we end up with 2 out of 5. Alright, I hope things are going well. And that is the end of 13.6.